Now that we've modified our molded wheel part, let's go ahead and modify something a little bit more complicated. Now, it's very easy for us to create parametric models of very standard, very simple solid geometry, like the molded wheel, like other examples that we've done. Because these are things like circles or squares or geometry that's very easy to predict when it changes. Now, what we have here is our complex part design 5 that we used in our complex part design, talking about features and making projected sketches and using splines. This is a much more complicated example, and it's much harder to predict what's going to happen. But again, it goes all back to our sketches, making sure that everything is grounded, everything is solid relations, and that allows us to do things like update the geometry. So looking at this design, what I want to do is I want to make a slightly different version of this. So I'm going to take this top face and I want to pull this edge over just a little bit. So that's going to reduce the bump that we have here and make maybe just more of a smoothed out version of this. So what we need to do is we need to figure out this edge and how to modify it. So to do that, I'm going to select this top face and notice that this is sketch 12, which is our cross curve here, and that belongs to boundary surface 2. Now boundary surface 2, if we select it in the feature tree, you notice that we get all these green arrows going back and showing us where it relates to. The front plane back to boundary surface 1, which was our helper, and it goes back to these curves, curve 1 and curve 2. When we select these, you'll notice that curve 2 is on the right-hand side and it shows us the 2D sketches that belong to it. Curve 1 is on the left-hand side and it shows us sketch 5 and sketch 8. Well, for us, let's select sketch 5 and let's edit it. We want to go to the top plane and really we want to pull this curve in just a little bit. So I'm going to take this 19 degrees down to 15 degrees and say okay. Now, because again, everything was solid and grounded, and we made sure that our projected curves had good relations by when we made, in this case, sketch 8, we actually physically brought in sketch 5. We brought in references. Remember, we split the surfaces up. We used our split lines so that we had a good solid place to locate these sketches. So that means that when we do things like change this curve, change where it's going, it's very easy for us to update this geometry. So let's say that, well, it's pretty close, but I want to modify it some more. Let's take this down to 10 degrees. We go down to 10 degrees and everything updates properly, but now things start to get a little crazy. These surfaces aren't really working out as well as we hoped. So now let's modify this one. This is sketch 13. So sketch 13, if you remember, we left underdefined so that we could come back in and we can simply move these lines and we can smooth it out. So I'm going to pull those edges in, say okay, let it update, and you can see that everything sort of smoothed itself out. But let's just say that we're not quite done here yet. Maybe I want to change the curvature as it goes across this. So sketch 12, now I want to modify sketch 12. As we look at it, let's just pull this point down a little bit, reduce the curvature, say okay. So now we've taken away that big bump on the right side. We've sort of flattened this out just a little bit so that the transitions are made a little bit nicer. So this is, again, a very complicated example because it's much harder for us to make these complex surfaces and really get them to update and follow along these sort of parametric guidelines that we can use for standard parts like machine parts or things that are just squares and circles and things of that nature. So when you make these kind of parts, when you make complex surfaces and you're building them off of these references, it's very important that we follow some sort of guideline. Now with this part, we started with a helper surface. This was going to be the base of everything. And this is a great way to do it because when we make our first boundary surface after this, we do things like select edges that are here. And as we go down the line, if you remember, we split this up so we had very specific quadrants. So these edges are fixed. We can attach our sketches to them. We can constrain to them. We can add our relations. We can add tangent relations and so on, and they're very easy for us to follow along. Then we can build our curves off of them. Now, the reason I'm going back and I'm showing you all this is because as we build these curves, it's very important because when we move these original sketches around, we can predict exactly how things are going to update. So in this case, let's say that we want to modify boundary surface 2, but we want to modify curve 2. This guy right here, we need to bring up a little bit. So that's sketch 11. Let's modify sketch 11 because that controls the height of everything. But that means that I want to go back and I want to show curve 1 and show exactly where it is. So in the middle, I want to take this point and I want to bring it up a little bit. I want to bring this one up. Just drag it up just a little bit and bring this up. So that way we're not dropping as drastically on the right-hand side. You can see that it updates. We can go back and we can hide curve one again, and then we can just roll the feature tree down, make sure everything updates properly. And of course you can right click on it and you can roll it to the end and sort of gamble and roll the dice and hope that everything updates properly. Now in this case, I know that it will because we were so diligent in getting everything to line up. But even though we know that it updated, you can see that we still have a problem here. Now, because we moved this edge up, it then affected some other underdefined sketches, sketch 16. So now we have to go back in here, we have to take a look at sketch 16 and see what happened. Now, because we move things around, sketch 16 is no longer a very good reference. We need to bring these edges out, we need to smooth things out and make sure that we don't accidentally add some relations back in here. So you can see that this point right here somehow got some sort of relation, and we want to make sure that drag it away and we smooth this curve out. That's a pretty good idea. Let's go ahead and say okay. And now there's still a little bit of a crease there, but we took care of that hard edge where our spline handles got moved around. Now, that should be an example of showing you exactly why you should always fully define your sketches. You want to leave some of these splines underdefined to start with, but in the end, you want to make sure that you work toward a situation where they're fully defined. You can also see that this surface, well, it's less than ideal. We're looking at it, it sort of pitches in right here. So we want to select it. It's boundary surface 5. We can go in and edit. And let's maybe drag it down a little bit farther, see if we get a better result, and say okay. Now, if you remember when we made these, we made this boundary surface, we knitted it, and then we did a filled surface here. And it's another thing that really helps us with these parametric updates because when we knit it, we have a very concrete, finite boundary that we can help blend these things into. And you can see here, because we're not going into a sharp corner, it sort of blends away unrealistically. So really what we'd have to do is we'd have to figure out a way to smooth that out. Let's go back into boundary 5. Instead, let's just drag it up a bit, get it closer to that curve. And you see that there's a curve there that's helping define that. Say OK, select it, and let's modify sketch 15. So sketch 15, we can sort of bring this edge in, we can smooth it out a bit, and that'll give us a better transition going into this bottom corner. So again, these are just different ways that we can manipulate these curves and manipulate these surfaces. And it does take a little bit of playing around with. And that's really why I wanted to show you this example because it's not as easy as just punching in a different dimension, moving a line around. It takes a little bit of work and you need to inspect your work and figure out what's best. But now we can hide edges, we can take a look and figure out where these surfaces are smooth and where they still need a little bit of work. You can see this patch right here, it's less than ideal. We can go back and we can tweak this a bit more, but in terms of an example, I think that's pretty good. It allows us to see the areas that we can work with and areas that we can call done.